First, as minister of this church, I take enormous pleasure in welcoming you to what is the 34th Paul Tillich Lecture. These lectures were founded in 1990 and have been under the curatorship since that day of William Kraut. He has brought this university distinguished scholars whose subject, of course, has been the thought, the work, and the life of Paul Tillich. Tillich had an enormous influence in the world, as we all know. He first taught at the Union Seminary in New York, and then, in a brilliant appointment by Mr. Pusey, was appointed university professor here at Harvard and made his home in the Harvard Divinity School. When the time came for his retirement from Harvard, he moved on to the University of Chicago. The name Tillich was, for many, many years, synonymous with public theology. Long before we knew the term public intellectual, Paul Tillich filled that category with great distinction. Even Time magazine recognized it, so that means it must have been so. When he lectured, the audiences were large and eager. And I'm happy to say that in addition to his lecturing, he preached regularly from that pulpit in this church to thousands in his time. He is perhaps the largest theological figure in our orbit, and so many of you have come here because of that fact. Not only do you remember a great mind publicly at work, but you have become interested in what others think of that great mind and that great work. That his memory is kept green here at Harvard is a wonderful thing for us all. I remember in the fall of 1965, when I entered the Divinity School, we were, as new students, mustered over here to the Memorial Church to attend the memorial service for Paul Tillich. Some of us thought that the glory had departed and it was all over. But we have long lived to realize that that memory and that legacy continues to flourish. And here on this occasion, we are yet again witnesses to its flourishing. Since 1990, we have had the privilege of enjoying these thoughtful excursions into the life and mind of Professor Tillich, and I know we will have that occasion and that experience again this afternoon. The Memorial Church is very pleased to be associated with Curator Kraut in this enterprise, and we would like to consider these lectures as an extension of our own public ministry. We are grateful to him, and we are grateful to have you here this afternoon for these purposes.
Good late afternoon. I don't even know if that expression exists in English, but I think that we understand it. First, I'd like to welcome you all and thank you for coming. I would like to thank the Reverend who pastors this great church for his opening remarks and his remarkable diction. I particularly want to thank first my dean here, Bill Graham, who I am finding to be a colleague, a friend, an historian that it is enjoyable to talk with. And Bill, not only do I thank you because I would not be here and have this opportunity without you, but I admire your courage in inviting a Jewish fruit fly geneticist who does not believe in God to the Divinity School. Okay. I think you're crazy. Bill Kraut, I'm glad that we have finally met, and I hope that whatever I have to say this evening will be in the tradition that you hope for. And then particularly I want to thank Gordon Kaufman, who just introduced me. Gordon is two major things to me. First, he is a lovely man, and he is a lovely mind, and I treasure him. I would not be here, and I would not have had the courage to write Reinventing the Sacred if Gordon hadn't told me that I was wrong on every other page. It was good to have his guidance. Finally, Nan Hutton is here this evening. Nan is a THD student in the Divinity School. And Nan has been the TF for the course that Gordon and I are teaching. She has been selfless, enormously creative, enormously able. She has kept Gordon and me in line, which is not so easy to do, particularly me. There's been many times that Nan's hand has been firmly on my arm saying, "Be quiet, please." And I'd like to thank the members of the class who are here. I have learned a great deal from you. And we are having a discussion group, many of whose members are here, meeting every Thursday evening. And I thank you all also. I have learned much from you, and frankly I hope the group continues in the fall. I have a lot to say. I hope that I'm able to say it in an hour. My title is The Open Universe and the Sacred. I've never quite talked on this subject. I want to invite you to consider three major things. First, I believe that we have to re-envision science itself in a way that will confound and alter the views that we have held of science roughly since Descartes and Newton. Second, I think we need to re-envision God. And following Gordon Kaufman, who has been saying this for 20 years, I too will want to say that God is the fully natural creativity in the universe. Third, because we have to face a re-envisioning of science, we confront an open universe in which, as we shall see, there may be no fundamental law down there, and we are set free from our moorings, anchored in reductionism. So that's the overarching set of things that I want us to talk about. We stand at a hinge of history. It could be an overused phrase, but much is happening. Most importantly, on a time scale of perhaps a half a century to a century, a global civilization of some form is emerging. It may be homogeneous. For example, we may all speak English and eat hamburgers. That's not so bad. I like English and hamburgers, but it really would be kind of tragic. Alternatively, we may have a forever diverse global economy. I hope for the latter, for reasons that I will give as we move along. As our global civilizations come together, and there are perhaps 20 to 30 of them, North American, European, Russian, Persian, Near East, Hindu, Chinese, Japanese, our civilizations are crushing together. As they do so, our ways of life are being challenged by our impacting one another. And one of the consequences is a retreat into fundamentalisms, often religious, often hostile, demonstrably lethal. We have to find a safe sense of the sacred that we can share across all of our traditions, whether we be secular humanists, which I am, Christians, Jews, Muslims, Taoists, Buddhists, Confucians, Shinto, across all of our traditions. We need something that's safe, that will welcome us into the world. I just point out that meanwhile we confront the obvious problems of peak oil, water, climate, and a population. We're in the middle of an economic contraction that may be verging on a collapse. It may in fact be calling into question our fundamental image of post-industrial Anglo-American capitalism. What are we going to do? So all of this requires new thinking. Now what I want to do is discuss our reigning worldview. It's the reigning worldview in the first world, originally the Western world, now the first world, and it is dominated by our scientific worldview, and that scientific worldview itself is dominated by something called reductionism. And if you haven't heard of it, I will explain it to you shortly. The founders of reductionism are our scientific heroes. It starts perhaps with Descartes, who gave us the mechanistic universe in about 1650, as well as analytic geometry and the Cartesian coordinate system, which is labeled X and Y. If they use other letters, they're wrong. Just bear that in mind. Then comes Galileo, rolling balls down an inclined plane, finding a law, announcing that mathematics and motion are the things to focus on, the primary qualities that Locke then attached so much significance to, reaching to Newton, that towering genius. Imagine what Newton felt like when the universe fell into place. How amazed he must have been. Then we have Einstein, and an Einstein scholar in the room, and Schrödinger. Among these, I want to single out Simon Pierre Laplace, a great French mathematician, who at the time of Napoleon said the following, the easiest view of reductionism. He said, were there a vast computing system, not a god, a computing system, and it had with it, we were able to give it the positions and velocities and masses of all the particles in the universe, that intelligence, using Newton's laws of motion and gravity, could compute the entire future and the entire past of the universe. All would be known to it. Past because Newton's laws are time reversible. There are 4 features of this reductionism. It is the view that is the simplest of reductionism, I've said. First, everything is deterministic. The becoming of the universe is entirely deterministic. That's because Newton's laws are deterministic. Quantum mechanics, under what's called the Copenhagen interpretation and the Born rule, shatters that a century later. But there are other interpretations of quantum mechanics that I won't mention. The second feature is the most important and the one I'm going to challenge. Please hear it. It is the view that everything that happens in the universe is sufficiently describable by natural law. Everything that happens is lawful. I'm going to try to persuade you this evening that that view is false. If so, I invite you to consider that it's a radical view. We'll see if you agree. Third, Laplace is telling us that ontologically the only things that are real in the universe are particles in motion. So a couple walking along the banks of the Seine, arm in arm, in love with one another, are really nothing but particles in motion. I don't think so, but Laplace did. And finally, and puzzlingly, Richard Rorty, a philosopher, wrote a book that I read that persuaded me of the 4th question, which I think is a deep one. Laplace is saying that there exists at least one language which suffices to describe all of reality. That language here are particles in motion and Newton's laws. But, asks Rorty, roughly, why should we think that we have a language capable of describing all of reality? We're just apes that learned to talk. Why do we have it all in our language? Hold that in mind. It's going to become relevant. Now, I'm going to short-circuit a great deal by compacting some of the first parts of Reinventing the Sacred to tell you the following. 50 years ago, all physicists were convinced reductionists. And the best way of capturing that is with Steven Weinberg, a Nobel laureate physicist, who says, and still says, that all the explanatory arrows point downward, from societies to people parts. I'm a doctor. I actually know that they're organs, but people parts will do. To cells, to biochemistry, to chemistry, and ultimately to physics, and to particle physics, and finally to Steven Weinberg himself. Okay. So that's reductionism. The universe will ultimately be a set of Russian dolls compacted together. When the science shall have been done, all will be explained because it will all be implied by or entailed by the fundamental laws of physics. Given that view, we think we know what it will be when the science shall have been done. I'm going to tell you that that view is wrong. We have to throw it away. And instead we're going to confront an open universe where there is no fundamental laws all the way down. And it's a very puzzling new place. The next thing that I want to tell you, and I'm a biologist, and I think in biology I actually can talk fairly clearly and firmly, I want to tell you why I think that biology itself, and evolution in particular, is not reducible to physics. So I have to begin with something that's going to seem strange. It's simple but profound. You all know that proteins are strings of amino acids that then fold up in your body and make things like enzymes. So there's 20 kinds of amino acids. A typical protein in you has about 200 to 1,000 amino acids, and they then fold up. So a protein length 200 is pretty small. Let's count the number of possible proteins length 200. Well, even if you're not mathematical, you can understand and calculate it with me. There's 20 possibilities for the first position, 20 for the second, 20 for the third, 20 possibilities for all 200 positions. So there's 20 times 20 times 20 to the 200th power possible proteins length 200. 20 to the 200th power is 10 to the 260th power. We could make any one of these proteins that we want to in the lab. I've actually done it. Not length 200, but a little bit shorter. Now there are 10 to the 80th particles in the known universe. The universe is about 14 billion years old, or 10 to the 17th seconds. The fastest time scale in the universe is the Planck time scale of 10 to the minus 43rd seconds. If all of the particles in the universe were doing nothing but making proteins length 200 on the Planck time scale, it would take, you ready? 10 to the 39th times the lifetime of the universe to make all proteins length 200 once. This means several things. First, it means that above the complexity of the atom, we will never, in gazillions of lifetimes of the universe, make all possible proteins length 200. Or if I made it 1,000, it would be even more gargantuan. We will never make all possible organisms, all possible organs, all possible social systems, and until a week ago I used to say all possible Chevrolets. There's an error in my reasoning, but I can't find it. Okay. This means, first, that the universe is open upward in complexity above the level of the atom in ways that we haven't thought about. It's indefinitely open upwards. There are skyscrapers, there are complex legal systems, there's stuff all over the place. We will never make them all. That in turn means that the becoming of the universe above the level of atoms is on a unique trajectory. It will never visit all possible states. Therefore, it's what the physicists call grossly non-repeating, and their fancy word for it is that it's non-ergodic. When the space of the possible is vastly larger than what will actually happen, history enters. I've just given you the physical basis for history. It's already there once we're above the level of the complexity of the atom. Now we could talk about it also for the movement of mass in the universe, but this will do. So history has entered the universe, and biology is history. Now I want to turn next to the following, now that I've told you about history entering. Suppose we were to ask Charles Darwin, what's the function of Stuart Kauffman or Gordon Kaufman's heart? I'll pick on Gordon. Darwin would say the function of Gordon's heart is to pump blood. Well, I'm a doctor, and suppose I said to Darwin, but you know, Mr. Darwin, Gordon's heart not only pumps blood, it makes heart sounds and wiggles water in the pericardial sac. Darwin would say, that's fine, but that's not the function of Gordon's heart. Gordon's heart has a function of pumping blood. And then I would say, well, what do you mean? Of course, I know what he would say. He would say it was selected and therefore exists in the universe because it pumps blood. And we would accept his explanation. Already this is interesting because you see the function of Gordon's heart, for a biologist, is a subset of its causal consequences. It's pumping blood, not making heart sounds, and not wiggling water in the pericardial sac. This is already important to state it briefly, because if Steven Weinberg had all the information about Gordon's heart down at the level of atoms and parts of atoms and quarks and gluons and fermions and bosons and all those little tiny things that these physicists like to play with, even if we assumed that he could deduce all the properties of Gordon's heart, which I'm willing to grant him for the sake of argument, actually they can't get to water. But let's grant it to him. Weinberg would have no way whatsoever of picking out pumping blood as being particularly interesting. Why is it more interesting than wiggling water in the pericardial sac? He has no way of differentiating one causal feature from another causal feature. To answer Darwin's question, Weinberg would have to become either an evolutionary biologist, or he would have to be able to either deduce or infer the biological evolution of the biosphere and the coming into existence in that historical process, that diachronic, not synchronic, not at the same time, but the diachronic process across time of Gordon's heart. Can he do it? Well, I'm going to tell you in a moment that he cannot deduce it, but let's ask if he could simulate it. He can't. And the problem is that quantum mechanics matters. You see, quantum effects, like a cosmic ray, can cause mutations in your DNA, which in turn might change Gordon's heart, or more importantly, Gordon's sperm cells or Gordon's wife's egg cells, and change the behavior and evolution of the heart. Quantum mechanics matters to the evolution of the biosphere. Could one accomplish what Einstein griped about, God playing dice with the universe, and simulate all the possible outcomes of all the possible quantum events, all the possible outcomes, not just the ones that happened, but the ones that might have happened? Well, no. It would take an infinite number of simulations. Besides, one would have to do it for the whole universe, and a good physicist would tell you that a computer that could do that would be so massive that it would form a black hole and no information could get out. The physicists have these clever arguments. When they get stuck, they create a black hole. So, black hole, no information, tough luck. Besides, suppose that you could carry out the simulation. How would you prove that you'd actually captured the quantum and classical behavior of the biosphere for the past 3.8 billion years? How would you confirm it? No way. So, I'm sorry, Professor Weinberg, you're stuck. You can't simulate it. Now I want to turn to what's going to be the most important theme of the first part of this talk. I want to talk about what are called Darwinian pre-adaptations. Darwin had a very wonderful idea. He said, you know what? A property of an organism of no selective use in the current environment, like jiggling water in the pericardial sac, might turn out to be of selective value in some other different environment. That's called a Darwinian pre-adaptation. It does not mean foresight. It just means, said Darwin, that there happens to be a property that turns out to be useful in a different environment. And the great Harvard paleontologist Stephen Gould, who died tragically recently, changed the name to acceptations to get away from the apparent foresight of the phrase pre-adaptation. So now I've told you what a pre-adaptation is. I'm going to give you 3 examples. These are central to the whole talk. Some fish have an organ called a swim bladder. It's a sac partially filled with air, partially filled with water. The level of water in the sac adjusts the neutral buoyancy in the water column of the fish. I think it's pretty neat. Paleontologists claim that the swim bladder arose from fish with lungs, brilliantly called lungfish. And the idea is that water got into the lungs of the lungfish, or some lungfish, and now you have a sac partially filled with air, partially filled with water. It's poised to evolve into a swim bladder. There's the picture. First question. It's not a trick question. Did a new function come to exist in the biosphere? Sure, neutral buoyancy in the water column. Does anybody doubt it? Hope not. Second, did it affect the future evolution of the biosphere? Sure, new species evolved. New kinds of proteins evolved as their genes mutated. New niches evolved. So it affected the becoming of the biosphere, and it affected the becoming of the universe, at least on our little speck of it. Here's a second example. You have 3 bones in your middle ear, incus, stapes, and malleus, that transmit sound from your eardrum to your inner ear. They evolved by Darwinian pre-adaptations from 3 adjacent jaw bones in an early teleost fish. But the adjacency of those bones mattered. Had one been in the skull, one in the spine, and one in the jaw, we wouldn't have gotten the ear bones. So what the physicists would call relational degrees of freedom matter. Once again, did a new function come to exist in the biosphere? Yes, hearing. Of course, it took the rest of the ear. Did it affect the evolution of the biosphere? Of course. Again, new species, new proteins. So it had consequences for the universe. I'm going to leave my third example, which is the evolution of the tractor for farming, for a moment. I now want to come to the central question. You ready? It's a real question. Do you think you could say ahead of time all possible Darwinian pre-adaptations for all organisms alive now? Well, you look at me and you'll say, I don't have any idea what all the organisms are that are alive now. And I'll say, I'll make it simple for you. Could you say ahead of time all possible Darwinian pre-adaptations just for humans? Could you say all possible Darwinian pre-adaptations for humans? Is there anybody in the room who thinks that the answer is yes? I'm not going to ask you all to raise your hands and say that you agree that it's no. I know that you all think that the answer is no. Feel your mind go blank when you start to think about how you would do it. It's really important to stop and experience this. How would you list all the possible Darwinian pre-adaptations of human beings? I want you to feel the agony of your confusion. Okay? I've now asked thousands of people. We all agree. Part of the problem is the following. How would we create this list? I don't even know how to start on it. How would we know we'd completed the list? Suppose the list is infinite. How would we have what the computer scientists call an effective procedure, like counting from 1 to infinity, of listing in some orderly way all possible Darwinian pre-adaptations, all possible selective environments. So we can't make a list of all possible selective environments and know that we've completed it. Further, how would we pick out the features of one or many organisms, like the 3 adjacent teeth in the fish, that might turn out to be Darwinian pre-adaptations? We simply have no way of even getting started on the problem. Can you all feel it? This is now a fundamental conclusion. I'm going to take it that you've agreed with me because I think that you have. Let's watch what it implies, because what it implies is radical. Let me define the adjacent possible. I'll start with a concrete case. Suppose I have a pot with 1,000 kinds of chemicals in it. Call that the actual. Let them react by one reaction step, And let's ask if there are new kinds of molecules in the pot that weren't in the original set of 1,000. Call those new molecules the adjacent possible of the original actual. Now this is perfectly well defined chemically under standard temperature and pressure and stuff like that. If we give a lifetime of, say, a femtosecond or a nanosecond as the minimum lifetime for a chemical species. So that defines the adjacent possible where we know what we're talking about. Now I want to use that idea to point at, because I can do no better, the adjacent possible of the biosphere. Once there were lungfish, swim bladders were in the adjacent possible of the biosphere. But 2 billion years ago, when there were no multicelled organisms, swim bladders were not in the adjacent possible of the biosphere. I've cheated a little bit because I've used the notion of adjacent, and I don't quite know how to define it, and somehow we have some intuition that it's right, but I don't think we have a metric on it. Now here's what we've agreed to. We've agreed to something that's fundamentally important and that we've never thought about. We really have no idea whatsoever of what is in the adjacent possible of the biosphere. We do not know what's in the adjacent possible of the biosphere. That means something that we haven't thought about. This lack of knowledge is not stopping the biosphere from evolving. Darwinian pre-adaptations are perfectly common in evolution. That means that insofar as the biosphere evolves by pre-adaptations, we do not know not only what will happen, we do not even know what can happen. This is fundamental. We do not know not just what will happen, we do not know what can happen. Hold that. This is central. Now, let's ask something. Can we make a probability statement about Darwinian pre-adaptations? Well, let's think about it. Suppose you flip a coin, a fair coin, 10,000 times. It will come up heads about 5,000 times with a Gaussian or binomial distribution. But notice that you knew ahead of time all the possible outcomes for flipping the coin. All heads, all tails, heads, tails, heads, tails, all the possible patterns, all 2 to the 10,000 possible combinations of heads and tails. Yes, you knew all the possibilities, or what the statisticians call the sample space of the process. Because you do know all the possibilities, you can construct a probability measure, and that's how come we can predict this Gaussian or binomial distribution. But we do not know all the possibilities of the adjacent possible of the biosphere via Darwinian pre-adaptation. We have no idea what they are at all. So we cannot make a probability statement about the adjacent possible and the becoming of the biosphere by Darwinian pre-adaptations. We're precluded from probability statements. Now there's another notion of probability due to Simon Pierre Laplace. He said the following: suppose that you're in a home, and there's N doors, and you're told that behind one of the N doors there's a treasure, but you don't know which door. He said, what's the chance that you'll pick the right door? And he said, well, it's 1 over N. That's not a frequency interpretation of probability like the coin flipping one is. And it became Bayesian logic and Bayesian probability. But notice that you knew the number of doors, N. We have no idea what N is for the biosphere and its evolution. So once again, we're precluded from making probability statements about the becoming of the biosphere by Darwinian pre-adaptations. Now let's ask, what's a natural law? Well, we either think that laws command the universe like traffic lights do. Nobody thinks that. What people think is that a law is a compact description of the regularities of a process, like Newton's laws or Einstein's laws. Let's ask if we could have a natural law for the coming into existence in the biosphere of swim bladders. Well, the answer is no. We don't even know that it can happen, let alone have a measure of the probability that it will happen, let alone have a law for the fact that it will happen. Does everybody hear this? We cannot have a law for the coming into existence of swim bladders in the biosphere because we do not know even that it can happen, let alone the probability that it'll happen. So we can't have a compact description for it happening ahead of time. Afterwards we can say, look at that, swim bladder. But we can't have a law. That doesn't mean that the laws of physics are broken. Carbon will not change into nitrogen in the lungfish. So we're not violating the known laws of physics, but there can be no law here. What I've just told you is of, I think, fundamental importance. You see, I began by telling you that since Descartes and Newton and Einstein and Schrödinger and Laplace, reductionism has believed that everything that happens in the universe is describable by natural law. The entire becoming of the universe is lawful. By saying no with me, with respect to describing the adjacent possible of the biosphere, all possible Darwinian pre-adaptations, you have, in fact, agreed that the becoming of the biosphere is not describable by sufficient natural law. And that means that that belief of Descartes and Newton and Einstein and Schrödinger and Laplace and Bohr is false. If this is right, it's a major change in our scientific and, as you will see, much more worldview. So this is no small thing that we are talking about. Now, the next thing to notice about this is something that we do not have in our physical science, although it's in history, but we don't talk about it. You see, in Newton we have what are called differential equations that are deterministic, like billiard balls bouncing around on a table. Or we have quantum mechanics, which has the famous Schrödinger equation, and on the Copenhagen interpretation, just probabilities of events. We have here something that's entirely different. The coming into existence of the swim bladder, or the ear bones, is both partially lawless, yet it's not random. The swim bladder made sense in the biosphere when it arose. That's why it was selected by natural selection, right? In the context of that organism in that environment, the becoming of the swim bladder was not a random thing. I mean, it may have been random that it arose, but having come into existence, it was selected. It made sense in that context. Its coming into existence is not random. It fits its world. That means we confront, and I'll give you more examples as we go along, but this means that we have to think about something that we've never thought about. It is a non-lawful but non-random becoming of the biosphere. No sufficient law, but still non-random, unfolding of the biosphere as the biosphere becomes more complex and creates niches for yet new organisms and new adaptations, as I'll come to. So does the economy. So let me turn to that now rapidly. Some Texas engineers, because you can tell Texas jokes, were trying to invent a tractor. And they took an enormous engine block and they mounted it on a chassis, big engine block because they wanted it to be a tractor. The engine block broke the chassis. Well, the engineers put it on bigger and bigger and bigger and bigger chassis, and it broke all of them. Until finally one of the engineers says, you know what, the engine block is so big and rigid that we can use the engine block itself as the chassis and hang everything off of it. That's how tractors are made. That's a Darwinian pre-adaptation. It's seeing in the engine block's rigidity a causal consequence that can be used for a new purpose. So the becoming of our economy is also filled with Darwinian pre-adaptations that we cannot state beforehand. Try to list all possible uses of the screwdriver. Well, you can screw in a screw, you can lever off a paint can, you can clean your ear with it, for little screwdrivers with cotton on it. You can scrape putty off a window. Just think what MacGyver could do with a screwdriver. Okay? Can we list all possible uses of a screwdriver? No. Furthermore, this bears on whether or not the human mind is algorithmic. There is no effective procedure to list all possible uses of the screwdriver. Yet, neurobiologists and cognitive scientists are persuaded that the mind must be algorithmic. I think they're profoundly wrong. Okay, now I want to get to theme 2. But let me conclude this. What I've just told you is that at least for the biosphere up, and we'll worry about it for the abiotic universe in a moment, we're confronted with a ceaseless creativity. In place of law, there's a ceaseless creative becoming that you need to feel in your guts. It's the becoming of the biosphere partially beyond natural law. There's no law for it, but it's not stopping the biosphere from becoming. It's not. The biosphere is still becoming, but not lawfully. You feel puzzled? I hope so. So, we now have to ask a new question, and I'm going to have to try to go reasonably fast because this is new and I have to kind of read it because I haven't talked about it before. I apologize. What lies beyond reductionism? And the answer is an open universe that is not entirely reducible to physics. And here's how it goes. If reductionism were complete, then all that comes to exist in the universe would be entailed by, hence explained by, physics. So this meeting would be explained by physics, and therefore our existence doing this would be explained. But if reductionism is inadequate, then our having this conversation is not entailed by physics. Then the universe is in a sense that we need to explore open. There's no bottom law down there. The Russian dolls don't jam together. They stand somehow free of one another in ways that we don't understand. It will not be as Weinberg thought. So we are in an open universe where there's no sequence of laws that can all be stitched together. Now, even in physics itself, the famous cosmologist Stephen Hawking has just written a paper doubting the existence of of a theory of everything in physics. The name of his paper is Gödel and the End of Physics. I won't go into it, but Gödel proved a theorem saying that even if you have the axioms of mathematics, there can be statements that are true in mathematics that cannot be derived as as theorems from mathematics. So they're called formally undecidable statements. And Hawkins is arguing that even in physics, there may be no final theory down there. Others in physics are beginning to think the same thing. Everybody is very confused. Even down at the bottom, there may be nothing. And to say a word about string theory, there are 10 to the 500th string theories, and it's actually not a theory. They are fragments that don't stitch together. Nobody knows what string theory is. Maybe there is no law down there. Maybe there is, but we sure don't have it. Okay, next. If we are not entailed by the fundamental laws of physics, why do we exist? Well, take heart. Okay, it's not so bad. The biosphere has been doing just fine, existing and propagating for 3.8 billion years, without being reducible to fundamental physics. So it can't be so bad. We're here, and we're going to go out to dinner afterwards. So something's all right, even if it's not reducible to physics. We just have to think, okay, anew. One of the answers to this question is the emergence of mutualisms in the evolution of the biosphere. So I'm going to tell you the story of Jenny. Jenny is a hummingbird, and Jenny is in a field of flowers, and she puts her beak in one flower, gets some pollen, gets some nectar. The pollen rubs off on her beak. She flies to the next flower, gets some more nectar from the other flower. Pollen rubs off her beak, and she's pollinated the second flower. Yes? What if all of the pollen had fallen off her beak before she left the first flower? It wouldn't have worked, right? What a strange thing it is that the stickiness of Jenny's beak is the condition of existence of hummingbirds and flowers and insects with sticky legs and flowers co-evolving with one another for 300 million years. Who would have thought that? Try to deduce that, Mr. Weinberg, Dr. Weinberg. You can't. Okay? But this is a mutualism. This means something important. As the diversity of creatures, the complexity of creatures, and the complexity of features in each creature increases, the number of ways that things can be mutualistic with one another increases. It's easier and easier and easier to find ways to help one another. But that drives the increasing diversity of the biosphere, which feeds back and drives just what we talked about, the increasing ease of making mutualisms. The whole biosphere is one vast mutualism. All that's happening is the sun is shining. This leads to what I call a hoped-for law for the biosphere. I want to believe that the biosphere's evolution tends to increase the diversity of organized processes that can occur as it invades an ever-expanding adjacent possible. The more species there are with the more features, the more adjacent possible there is to go explore. The same thing is true in the economy. So, in the economy, 50,000 years ago, there were 100 goods and services, or 300 goods and services. There's now 10 billion in New York. Maybe 9 billion now. I mean, it's a tough time. How did we get from 1,000 or 300 to 10 billion? Well, what happens is that as goods and services come into existence, they create niches for one another. Screw and screwdriver are complements, screw and nail are substitutes. There's a vast economic web of complements and substitutes. And you can ask the following question. The economic niche of a good is its complements and substitutes. As you create a new good, how many new niches do you create? If you create more niches than one, then for each new good you get more niches, so you get the possibility of invading the adjacent possible in an explosive way. That's what's happened. And that suggests something that the economists haven't recognized. The very diversity of the economy drives economic growth. And that's not part of the theory of economic growth. I know. I've been arguing with the economists for something like 20 years about this. But they don't believe biologists. You have to be a card-carrying economist. The economists are almost as stubborn as the molecular biologists. I've been arguing with them for 40 years. Okay. In order to finish in time, I'm going to jump just slightly ahead. I want to ask, what are the implications of all of this for humanity? Well, for the Enlightenment, reason is the highest human virtue. It is for the Greeks, too. If we do not know what can happen, reason is an insufficient guide to living our lives. It really is. Therefore, we need all we've got. We need reason, emotion, intuition, imagination, story, and in particular metaphor. Metaphor is the imprecision of language. It is the evening of my life that allows one to span across that which one cannot yet say. It is the imprecision of language that allows us to cover and speak about and discover the adjacent possible, for example, in business. This raises profound questions. How do we actually live our life when we cannot know what's going to happen? This is not an abstract problem. I have friends in this room who have the role of being presidents of small companies. They are living their life going into the adjacent possible all the time. I know because I've done it too. They don't know what's going to happen. They don't know what can happen. And if you think it's impractical, think about trying to assess risk in the current market environment and technological environment when new technologies can drive your technology to become worthless. And yet, the banks have done just that. And you know the mess that we're in. So this is not a small issue. This is a huge issue. This is the issue of living our real lives in the real world, not knowing, and we don't think very hard about how do we do it when we cannot know in the policy world and elsewhere. And now I want to turn to theme 4, a shareable sense of God across all of our traditions, theistic, secular, wisdom traditions of the East, as we co-evolve our civilizations together. I don't believe in a supernatural God. I believe with Gordon Kaufman that God is a human-invented symbol. It's our most powerful symbol. It's a dangerous symbol. There are those of us who are scientists who remember Galileo and the Inquisition. We want no truck with a sense of God that says you will go to the Inquisition if you dare challenge the authority of the Church. On the other hand, there are those people who are profoundly religious in a traditional, say, Christian sense, for whom the idea of reinventing the sacred and seeing God as something other than a supernatural God is literally sacrilegious. I would not argue with them for a moment. What we need is a sense of God that can be shared across all of our traditions. Let's distinguish, as Gordon Kaufman has, and Gordon has been writing about this for 20 years. I recommend his book, In the Face of Mystery. He's been talking about God as the natural creativity in the universe for a long time. My arguments, I hope, are a scientific backing for what Gordon has been saying. I want to say with Gordon that God is the natural creativity of the universe. We have slightly different senses of it, but the cornerstone of it is much the same. It's our symbol. We can use it as we want. Now, if we say that God is the natural creativity in the universe, certainly the biosphere up, maybe if Hawkins is right, the abiotic universe as well, we'll see in the next 20 years. Maybe the universe all the way down is creative in ways that we don't know, just as it is for the biosphere up. Then how do we use this sense of God, which is not a creator-agent God, whose creativity we're used to in the Abrahamic tradition, but just the creativity of God, God as the creativity in the universe? How do we use that to orient our lives? So I'm going to tell you a personal story. I live in a little town outside of Calgary called Bragg Creek, and we have a patio that looks on a beautiful little hill that hides the Canadian Rockies, which is both sad but lovely because the hill's lovely, and it has spruce and aspen on it. And I was sitting out there one evening 2 summers ago with, I confess, a glass of scotch, not much drunk, and I looked at the aspen, and I looked at the spruce, and I said, you know, I could cut down those aspen and spruce if I wanted to. And then I said to myself, but in my sense and Gordon's sense of God, that's God's work. How dare I? And then I looked at the little stream, and I said I could dam the stream, blow it up with a couple of tons of TNT, take all the fish and destroy the river. And I said to myself, how dare I? That's God's work. I invite you to try this. You'll find that if you walk amidst streams and fields, that you will feel a membership with the creativity of the universe. You see, if God is this creativity, then all that's been happening for 3.8 billion years is that the sun has been shining and the biosphere has blossomed. And our cultures have come to exist down the centuries with their rich wisdom, their rich traditions, and their stupidities. All of this is enormous creativity. It's ours. If you feel it, you will feel a sense of membership with all of life. You see, in this view, we are not made in God's image. We too are God. But so is the lichen, and the tree and the worm and the jellyfish and little polyps. We're all God's children. That means we are united in membership. We're not alone. It also means that you cannot help but feel invited to a sense of stewardship. Now, what are we going to do with that stewardship? We do not know what can happen. So a consequentialist theory of ethics that says, act for the greatest good of the greatest number, a la Bentham, which has much to recommend it, is a little difficult. We don't know what the consequences of our actions are going to be, but we have to be as wise as we can be anyway. Too bad. That's life. We have to do our best. So, I want to touch upon a couple of other topics now. What are the grounds of hope with such a naturalistic religion? Well, I think there's two, at least. One, I do really think that the biosphere and the economy and our culture have not only evolved altruism, but altruism itself is a form of mutualism. I'll help you if you help me, but then Jenny helps the flowers and the flowers help Jenny. So it's really true, I think, that as the biosphere has gotten more complex and diverse, and as the economy has, and as our cultures have, the ways of forming mutualistic interactions, positive-sum games, not zero-sum games, have become easier. A friend of mine is here who's a political scientist, and Walter likes to think of talking to the Iranians and saying, instead of making war, why don't we build pathways whereby we share and have positive things to share, and even if Ahmadinejad wants to destroy Israel, he will have more to lose than to gain, and unless he's too crazy, which is possible, he will share. And the mutualisms will win out over our tendency to want to kill one another. We do, if we don't enjoy it, we do kill one another a little too easily, as we all know in the past century. Now let me talk about a global ethic. We must find our way to a global ethic. Ethics requires at least two things. It requires the reality of values, and it requires the notions of a responsible free will. In physics there are only happenings, and there's the famous naturalistic fallacy of David Hume, who said you cannot deduce an ought from an is. But Hume meant an is in the physics sense of a happening. We are not happenings, we are agents. I've written a lot about it. We do things. For example, you're listening to me, and we'll all go have dinner. Once you have agency and doings, you have value. A bacteria swimming up a glucose gradient, and it's either yuck or yum. Once you have values, you have oughts. So Hume has it half right. He's right that you cannot deduce ought from is, but you cannot deduce agency from physics either. And once you have agency in life, you have values, you have doings, and you have oughts, and you have moral reasoning. So oughts and values are real in the universe once there's life and agency. I'm just going to mention the tough problem of morally responsible free will. These are deep problems in the philosophy of mind. This goes back at least to St. Augustine. You see, it's either deterministic, like Newton. Our brains are either deterministic, or it's chance, like quantum mechanics. Well, if our brains are deterministic, we can't have a morally responsible free will. It's deterministic. If it's chance, well, I was walking down the street and I killed Joe. Chance. I'm not morally responsible. Nobody has had an answer to it for 350 years. I want to suggest a pathway to begin to think about it. We have something new in our armamentarium. We've discovered that there is a partially lawless, non-random becoming of the biosphere, of the economy, of our human culture, and by a stretch of the imagination to be turned into philosophy, then science, of our mind. If we can have a partially lawless but non-random unfolding of consciousness acting on or having consequences for matter, we will have the possibility of a morally responsible mind. We're not there yet, but it's a new pattern of thought. Now what about the sacred? How many gods have we worshipped in 100,000 years? Lots. All of our gods have told us what is sacred. Whatever your beliefs, do you get the suspicion that down through 100,000 years, we've told our gods what is sacred, and they've told us what we told them? Maybe we've been talking to ourselves. But that's not bad. It means we've always had a sense of what is sacred and projected it onto our gods. But that means the following. Are we at a point in the evolution of our cultures, and a global culture, when we can begin to take conscious responsibility for those values that we will deem sufficiently high, unquestionable, that we will deem them to be sacred? It's our responsibility, not God's responsibility, what we will deem to be sacred. And it doesn't mean it's not sacred. And it also doesn't mean it may not change and evolve over time. The last thing we need is a Maoist moral hegemony. We need ways of evolving our traditions wisely. So we need a global conversation to try to converge on a global ethic that will guide a global civilization that's emerging. I'm going to end with a few sentences about a vision of a global civilization. This is partially a conversation with none other than Nan Hutton, Gordon Kaufman, and myself a few weeks ago, and we were talking about this. And we came to an interesting phrase. It was the networked global civilization. And here's what I have found myself thinking about it. As opposed to we all speak English and eat hamburgers, or we all speak Chinese and eat chow mein, or at least kung pao chicken. What if instead we think the following? We remain rooted in our ancient civilizations. They evolve slowly. To try to do other than evolve them slowly is both foolish, unwise, and unworkable. They contain deep wisdom as well as deep tragedy. If we begin to talk to one another across our traditions, as the world culture emerges, to the right degree, and I don't know what that is, what the right degree is, if we crosstalk, we will invent new cultural forms. One way of saying it is that you can get Chinese Cuban cuisine in New York. Another image is what will happen if they play hard rock from the minarets in Saudi Arabia. I don't know, but it'll be interesting. What if we envision the following? Think for a moment of laws like contracts as enabling constraints. Given a law and the enabling constraint of a contract, you're enabled to do things that you couldn't do otherwise, like make a company and go out and try to do something good for the world, or be greedy and get rich. So laws are enabling constraints that enable us to do more things. Our laws and norms create those possibilities inside of which we play our games. Now, let's take a simple question. Could you cash a check 50,000 years ago? No. Think of the vast array of social inventions, to use Gordon's phrase, of us as biohistorical creatures, that has allowed us to cash checks. What if we envision the becoming of a global civilization whose primary dream it is to maximize the organized diversity of what we can do as human beings, and in that profound sense, maximize our freedom and capacity as human beings? That doesn't mean we don't need an army to take care of people who are evil. It doesn't mean that we should be pie-eyed and utopian. but it's a direction to think. What I'd like to do now is close. And I'm going to close with the following. It's from Micah, 800 years BC. He has told you, O mortal, what is good. And what does the Lord require of you but to do justice, and to love kindness, and to walk humbly with your God? Suppose Micah were alive today and in our class with Gordon and me and our younger fellows, and we had a view of God not as the creator agent, but the mere glorious creativity of the universe. Not an agent God, just the creativity of which we are the children. I think Micah would say, O mortal, what is good? To do justice, to love kindness, and to walk humbly with your God. Thank you. Thank you. Is asked whether or not I will take questions. Of course. You're right, there's a microphone here, and I think that probably, if it's convenient for you, I would play the role of dance director and ask you to use the microphone so everybody can hear.
Well, your remarks covered such a wide space. I'm sure it's provoked hours of questions. And I thought Professor Gomes was pointing at me instead of the microphone, which is why I decided to come up with a question for you, or a comment, I guess. I think you've done a good job of demonstrating that creation hasn't been a process that you could describe by determinism, but I don't think that's the same as proving that we don't have a creator God. We can talk more about that later.
But I'm glad to talk about it now, too. May I make one comment?
Well,
back to you.
Just make a couple more, and then I'll turn the floor back to you. You suggested that we haven't yet gotten to a morally responsible mind. Maybe we haven't discovered one yet. I haven't had the opportunity to meet the Dalai Lama. Maybe you have. And I guess the last observation I would make is the notion of mutualism and its application to biological systems. Before we totally celebrate that, remember that there's also within mutualism parasitism, which exists in economic systems as well.
Sure.
Okay.
So you've raised 3 points. Just remind me, the first point was what? About theism. Of course this does not disprove the existence of a theistic God. First. It could not. I don't believe in a theistic God, but I do have this to say, and I think that it's comfortable, and I'd be curious what people think. If you think of the Newtonian universe, a deterministic universe, it gave rise, as we all know, to deism, which was the idea that God wound up the universe according to Newton's laws, set it in motion, and then sat back and watched it unfold, but did not intervene in its unfolding. That was the view of the Scottish Enlightenment, philosophers such as Hume and Adam Smith and so on. So deism was a natural consequence to taking Newton seriously and trying to square it with some sense of God. While I do not believe in a supernatural God, if one envisions the open creativity of the biosphere becoming, of our economy becoming, of our cultures becoming, partially lawlessly, maybe the entire abiotic universe becoming partially lawlessly, that seems to afford a rich place in which a theistic God might act. Now, I don't believe that, but I see nothing that prevents such a belief. The second question you asked, I think, was about a moral mind. I had the chance to meet the Dalai Lama, but was unable to take it a number of years ago, and I know that he was just on campus. That's a moral mind. It's not that we don't know moral minds, we have them. The question is, and it arises in the philosophy of mind in Western science, if you believe science, if you believe either in Newton's determinism or in quantum mechanics and the Copenhagen interpretation, you either have full-blown determinism, in which case you cannot have free will. Here's why. In determinism, everything that happens has sufficient antecedent causes that determine them. Then, as Aristotle noted, there can be no uncaused first cause. You have to have causal closure. So you cannot have free will, and even if you could have free will, well, it's silly, you couldn't have free will, and anything that you did would be deterministic, so if you killed Joe Blow, it's not your fault, you were determined to do so. It's a philosophy of mind question. Alternatively, suppose that mind is quantum, which I happen to argue in chapter 13 of Reinventing the Sacred. I think it's improbable scientifically, but possible. It's philosophically very interesting. If you take a quantum event like the radioactive decay of a nucleus that just happens and all you can do is compute its probability, then it's just pure chance. So it's just pure chance if that's your free will. You have a free will now because it's not causal. The Copenhagen interpretation is an acausal interpretation of quantum mechanics, so the problem of causal closure doesn't come up. But it's just chance. So you're not morally responsible. You have a free will without moral responsibility. What I'm seeking for, because a quantum interpretation of mind answers other philosophy of mind problems, is an interpretation in quantum mechanics. It's the analog of the non-random, the partially lawless but non-random becoming of the biosphere that would allow a quantum mind to behave in the same way, that would then be intention. And then just to tell you a little teeny bit about the idea, the question is how do you get from the quantum world to the classical world? And the favorite interpretation now is something that's called a decoherence. Well, without going into it, decoherence from the quantum to the classical world is not causal. And the beautiful feature of this idea is, since Descartes we've wondered, how does mental stuff act on physical stuff in dualism? Nobody's had the answer since Descartes. Nobody. If you take the view that mind is quantum, but decoheres to classicity, that is not a causal process, yet a quantum mind can have consequences for the classical physical world. And it answers the major philosophy of mind problems. I just have to solve morally responsible free will. And I think it's kind of close, but I don't know. Other questions?
You mentioned the example of the heart being selected to pump blood. Is there a parallel in the physical world, for instance, like the law of gravity? Was it selected somehow by some process to exist?
Hamid, we just met today, but we're already good friends. You give me a chance to say some stuff that I would have said that is at the edge of contemporary physics and just over the edge. So I'll tell it to you. Take it with a very large grain of salt, okay? So I told you that Stephen Hawking said, Gödel and the end of physics. And I explained that to you, that there's this possibly infinite set of laws. There's another thing that is known, Dirk Ertz is a quantum physicist in Brussels, who told another guest here, Liane Gabora, and I, a couple weeks ago, that it is well established in quantum physics that if you take the well-known Schrödinger equation for how quantum phenomena propagate and quantum measurement, which, as you all know, is the two-slit experiment, and the photons go through the two slits, and you see the interference pattern. The seeing of the interference pattern is the measurement phenomena. Nobody understands it. What Ertz told us is an established theorem is that the combined process of the Schrödinger wave plus measurement cannot take place on a definable set, like a set of oranges, or a chunk of space-time is a set. It cannot take place on a definable set. And Dirk and Liane and I grew excited as we realized that's deeply similar to my saying we do not have a definable adjacent possible for the biosphere. Now I'm going to get to point 3. I was just in Belgium, and another set of colleagues and I are just looking at a theorem that is based on what's called Bell's inequalities. And this is claiming, the theorem that Bernhardt proved is the following. If you think that you have a chunk of space-time in a measurement apparatus, then the following claim produces a contradiction. A, there's an exhaustive description of this set of space-time plus the measurement apparatus, and there's a law that maps that into what happens. That cannot always be true. That sounds like Ertz's view, where there's no set that's definable. 2 more things gets us to my dream. Hans Briegel, a quantum physicist in Innsbruck, has recently published 2 articles that I think the physicists are accepting, that says you can go from being quantum possible to being classical actual, or classical for all practical purposes, and back again, that it's reversible. Okay? Once that's true, the following question arises. If you can go back and forth between quantum and classical, what determines whether or not a little chunk of classical matter resists going back to being quantum? Okay? Now either there's a law for that, or there's not. I happen to think there's not. I won't say why. If there's a law for it, it must be an extremely complicated process by which classical matter comes to exist and somehow survives against the reverse process of being quantum. If there's no law for it, we'll get to just what you asked for, which is an abiotic natural selection process which is lawless, in which classical matter that is constituted such that it tends to resist returning to the quantum haze persists, just like saber-toothed tigers do, and therefore propagates in the world, and it's an abiotic natural selection. So in the next year we hope to explore all of this, and what's fascinating to me about this possibility is it would mean that way down there, where Hawkins says maybe there's no law, the natural selection that I'm just intuiting, beyond where we know now, do not believe me, just hear that this is an interesting idea, would be lawless, just like the becoming of the biosphere is lawless. And yet it would happen, and just like the biosphere is doing fine, the universe seems to be doing pretty well too. Now I don't know about gravity and other things, but I have wondered whether there were exactly what you've said, Hamid. Could there be a selective process that picked out the laws? And I actually talk about that in my 3rd book, Investigations, where I propose a possible what's called vacuum selection principle that could pick out the laws, but not by natural selection, but by a lawful process. So one mind starts to reel somewhere at this point. But if we think of the universe as being open in the way that I'm talking about, it throws open our understanding to all kinds of new thoughts, because we thought the Russian doll story was going to hold, that reductionism would work. We've thought it for 350 years. It looks like it's wrong. Now what? Well, we don't know. We have to think and feel and intuit and imagine and have metaphors. Chris. This is the last question, Chris. So Chris and I started BIOS Group.
Stu, I'm wondering if you haven't said something stronger than what you're attributing to Stephen Hawking, namely that you said maybe there's no theory of everything, maybe there is. I think you've said there isn't. And here is what I have taken from your talk to put that together. That first, you said we don't have laws of physics. We agree that or of science, that what are sometimes called laws are compact descriptions of the regularities we observe. But you also said we observe the pumping of blood, not the pericardial turbulence, but that's a choice, because it may be that in the long run we care more about the pericardial turbulence. Right? So the laws, these compact descriptions, are of the pumping of blood, but not of all the things that may be interesting about the heart or the gluon. But if that's the case, then a theory, you've also said not every context is pre-statable. But a theory of everything would have to describe the things that you've said can't be pre-stated.
Right.
So I don't see how you can admit of the possibility, then, of a theory of everything, because you can't know what everything means.
So a couple of comments. Of course we do have laws. We have Newton's laws. We have Einstein's laws. Gravitational lensing happens. Our satellite systems depend upon general relativity. So there's no doubt that we can have laws, and we have them, and physics is full of them. The question is whether or not the entire becoming of the universe is describable by sufficient law. That's what I'm denying, Chris. And if that claim is true, I think I agree with you. I think it implies there cannot be a theory of everything that has the property that all that occurs in the universe is entailed by that theory. I don't think that theory exists. That's why I say we are living in an open universe where the biosphere is doing just fine. And I didn't quite say this, but let me say this because it's the last question. The biosphere is inventing its own laws by which it evolves. Watch. We are sexual organisms. Sex is a big puzzle in evolution because it takes a mom and a dad. There's a twofold loss in fitness in order to have sex, and lots of species are asexual. Sex gives rise to, depends upon meiosis, which in turn gives us Mendel's laws. Sex is thought to have evolved because it helps us evolve more adequately on what are called smooth fitness landscapes. On bad fitness landscapes, it's no help. Another question is where do the good landscapes come from? So the biosphere is evolving its own capacity to evolve. This is stunning. But cultures are evolving their own capacity to evolve. Think of the British legal system and how it evolves. Business evolves its own capacity to evolve. Think of the efforts right now to re-regulate the banks. So, in all of these cases, we're making our own laws. And I have an image that I'm falling in love with, Chris, and let's make this the last remark. If you think about cultural evolution, historical evolution, the evolution of the economy, the evolution of the biosphere, it's as if these systems all build some kind of internal skeleton for themselves of laws and norms and constraints and enabling constraints, around which they vary slowly, that can explore the adjacent possible. There's so much we have to discover, Maybe we evolve in such a way that we explore the adjacent possible in some optimally efficient, rapid, productive way. I don't know. We've never thought about it. But it's an open universe. Thank you all. Thank you.
I rise to thank you all for attending this lecture this evening and for listening and receiving so well what Professor Kaufman has had to say to us. Some of you will remember that great line of Alexander Pope, "Nature and nature's law lay hid in night. God said, let Newton be, and all was light." Poor old Alexander would have a very difficult time with you, sir. And I think he'd have to revise his little quatrain. And why not? You've heard it here. Thank you all for coming this evening. These lectures are now adjourned.